Hi, this is the experimental setup of the circuit diagram to determine input output characteristics. Input output characteristics. Input output characteristics of CE configuration. Common emitter configuration. It is a circuit diagram of input output characteristics of CE configuration, common emitter configuration. Now let me see. This is a transistor which is having a emitter base collector. In this, emitter is grounded. Emitter is common. Emitter is common for both the input and the output. So this is the input. So this is the input part and this will be the output part. So emitter is common for both input and output. So in this, emitter is to be grounded. Emitter is to be grounded. Base is to be connected to the ammeter and the voltmeter. And the ammeter is to be connected to the resistor. And this is to be connected to the RPS supply. Supply is varying from 0 to 30 volts. So this resistor is a 100 kilo ohms, 100K. And ammeter is a micro ammeter, is to be having the range of 0 to 200 microamp, and voltmeter having the range of 0 to 10 volts. And in the output part, this collector is to be connected to the ammeter, which is having the range of 0 to 200 milliamps, and through the resistor it will be connected to the supply of 0 to 30 volts, and a voltmeter is to be connected having the range of 0 to 10 volts. In this, emitter is common. Base is to be connected to the ammeter negative and the voltmeter positive. Voltmeter positive. And the voltmeter negative is to be connected to the ground. Voltmeter negative is to be connected to the ground. Next. This ammeter positive is to be connected to the resistor one terminal of the resistor. And second terminal of the resistor will be connected to the RPS positive. RPS positive. So supply positive. And negative is to be connected to the ground. Negative is to be connected to the ground. And similarly, the collector. Collector is to be connected to the ammeter positive. Ammeter positive. And ammeter negative is to be connected to the one terminal of the resistor. And second terminal will be connected to the RPS positive. RPS positive. And negative is to be grounded. Negative is to be grounded. And this voltmeter positive is to be connected to the junction, or this voltmeter positive is to be connected to the ammeter negative, and voltmeter negative is to be connected to the ground. So in order to find the input characteristics and output characteristics, the input characteristics, the output voltage is to be kept maintained constant. This is the voltage of VC. The voltage of VC is to be maintained as constant. This is to be kept constant. And in order to find the output characteristics, this input current is to be maintained as constant. Input base current is to be maintained as constant. So the input characteristics and output characteristics are to be determined by using the circuit diagram as shown in the figure. And these components are to be connected on the breadboard as represented emitter base collector term with ammeter, voltmeter and power supply and resistors. Okay. So these input characteristics between the current and voltage, and the output characteristics also to be between the current and voltage. Now to find the input characteristics of this CE configuration, output voltage to be maintained as constant. This has to be maintained as constant. That means this may be kept at 0 volts, or it may be kept at 2 volt or 3 volt or etc. By maintaining it as constant, vary this VBE terminal, this RPS supply, varying this terminal, note down the corresponding readings of ammeter and voltmeter, And similarly, in order to find the output characteristics between the current and voltage, this input current, that is base current, is to be maintained as constant. This will be maintained at 5 microamps 10 micrograms, 15 micrograms. By maintaining 5 micrograms, where this battery or the RPS, corresponding readings of ammeter and voltmeter are to be noted. Now we can see how the tables are to be formed of this configuration. Now the input characteristics. Let you represent these are the input characteristic determination of the table. So it is to be maintained as a VCE as constant. VCE equal to 0 volts. So for this VBE, it is the base terminal VBE, and this is the base current IB. And similarly, another reading is to be maintained as constant. VCE may be 1 mole. To this, note on the corresponding readings of VB and IB, and similarly, one more you can take VC equals some 2 volts. Note on the readings of VB and IB. So in order to find the input characteristics, the output voltage is to be maintained a constant. Initially it is 0 volts, it is to be kept at 1 volt, it is to be kept at 2 volts. If it is to be kept at 0 volts, where is this power supply? Varying from 0 to 30. Note on the corresponding readings of ammeter and voltmeter. So let you take this reading may be 0.1 milliamp microamp. So it is in microamp. And 0.2 microamp, 1 microamp, it is 0.3, 0.5, 1, 1.5 and etc. Correspondingly, note on the readings of VBE in terms of the voltage. By varying this terminal, by varying this RPS, the ammeter reading and voltmeter readings are to be taken with a variant of 0.2, 0.3, 0.5 and etc. For 0.2, what is the value? For 0.2, for 0.3, for 0.5 and etc. And similarly, at 1 volt, it is to be kept at 1 volt. By keeping at 1 volt, where this RPS, corresponding readings of ammeter and voltmeter are to be noted in the similar pattern. And next, this to be kept at 1 volt, 2 volt, where this RPS, power supply, note on the corresponding readings of ammeter and voltmeter, After noting down all the readings, you can draw the input characteristics. So these are the input characteristics model graph. So here VB along the x-axis in terms of volts and IB is along the y-axis. Note on the corresponding readings. Maybe this may be the 0, maybe the curve of the first value model graph. So this will be corresponding for VC equal to 0. So it is for 0 volts. And for 1 volt, let you take for 1 volt also. So this may be the model graph for 1 volt. So it is for 1 volt. VC equal to 1 volt. So VC equal to, and this VC equal to 1 volt. VC equal to 1 volt. And similarly for 2 volts, let we consider this is for 2 volts. VC equal to 2 volts. So like this, you can draw the input characteristics of CE configuration. And similarly, the output characteristics are also determined by using the or by maintaining the input current IB as constant and input current IB as constant. Let us see the table and the model graph of that output characteristics. So for the output characteristics, this current is to be maintained as constant. IB is to be maintained as constant. Maybe this may be at 5 microamps and IB may be at 10 microamps, and then IB may be at 15 microamps. This is at 15 microamps. Corresponding readings of voltmeter, ammeter is to be taken. Let us take this, it is VC, this is VC and this one is IC. It is VC and IC. VC and IC. Now, by maintaining this input current IB as constant, by varying this RPS power supply, we can note down the readings of ammeter and voltmeter. That means collector current and collector emitter voltage. IC and VC are to be noted. To note this, let us take this may be at 0 volts because it is varying from 0 to 10 volts. It may be at 0.5 volts, maybe at 1.5 volt. It is 2 volts, 2.5 volts, 3 volts, and etc. up to 10 or 8 volts. Correspondingly, you can note down the readings of this ammeter reading, IC reading. And similarly, this also for 0.2 volts, 0.5 volts, 1 volt, 1.5 volts, 2 volts, and etc. Similarly, here also corresponding readings are to be noted to this 0.2, 0.5, 1, 1.5, and etc. And after noting that all the points, we can draw the graph of this output characteristics. Output characteristics graph can be drawn. The output characteristics is in between VC and IC. So let us take this along the x-axis is VC and along the y-axis is IC. IC is in milliamps and VC is in volts. Let me consider the model graph of the first experimental value for VC and IC. 0.2 volts may be the some value, 0.5, 1 volt, 1.5 volt, and etc. Let me take the model of this one, maybe express this for 0.00 volts, 0.5 volts, 0.3 volts, and etc. And after noting down all the readings, by joining, you may have this type of curve. And similarly for the second one, let me consider for the second one, and for the third one, So it is for IB equal to 5 microamps. It is 5 microamps. It is for IB equal to 10 microamps. It is for IB equal to 15 microamps. IB equal to 15 microamps. And after drawing all the curves, there may be 3 regions may exist. One is the cutoff region. Below this region is a cutoff region. So this is the cutoff region. So it is the cutoff region. A line is there. Let it be O, and this may be the point A, OA line. Left of the OA, this region is called as a saturation region. Saturation region. And after this line, after the line OA, all the lines are to be straight line. After this line, this may be considered as the active region. So it is the active region. Therefore, we can say in a CE configuration, output characteristics, we can observe the 3 regions. One is the cutoff region, saturation region, and the active region. So it is a way to determine the input-output characteristics of CE configuration. Okay.